Okay, so we have a question in the book where we are given the number of sticks for a different series, and you're asked to just fill in the series. Figure number 1 has 3 sticks, figure number 2, 5, 3, 7. So we can easily see the interval here. This interval here is extremely useful. The formula for number of sticks for any number n can be defined as the difference, when the difference is constant, times n plus the start number. The start number we get for figure number 0, which really wasn't in this question. The start number is, we have to go back, and instead of starting at figure 1, we have to think, how many sticks did we have at this fictive number, figure 0? So we go back to figure 0. If we were going to go back from one figure from 3, what would we do here? We'd actually have to take away 2, because we've been adding 2 each time. So we would get that there is 1 stick in figure number 0, because we go back minus 1 here. Each of these is the figure number before. So figure number 0 would have had 1 stick, so the start number is plus 1. And the difference is 2 between each one. So our formula for number of sticks, or S, is 2n plus 1. So we now know what the formula is. This question later on is asking us to plot the graph and work out from the graph what the number of sticks is at figure number 8. So if we're going to work out figure 8, and we're going to be able to plot the graph nicely with the right axis, we actually need to know what will the number of sticks be at figure 8. Well, S is going to be 2n plus 1. We've worked out the general formula here. So it's going to be 2 times 8 plus 1, which is 16, plus 1, which is 17. So we know that at figure number 8, we need to have at least the number 17. So we now have that we can have the x-axis all the way up to and including figure 8. The y-axis has to go at least as high as number 17. So I've taken intervals of 2 here. We can plot the points on the graph. Figure number 1 is going to be at point 3. Figure number 2 is going to be at point 5. And figure number 3 is going to be at point 7, halfway through here. We now have our points. You need at least 3 points for every straight line equation. And now we can just join them up here. And extend up here. And you've got better lined paper than I've got. Extend it all the way back up to figure number 8. And if we're going to work out graphically what is the number of sticks using our graph, we actually go up figure number 8 and then we go across. At figure number 8 we can read off that there would be 17 sticks. So the important parts of doing this problem are first being able to work out how high you need to do your y-axis. Label your y-axis. You don't call it y-axis. This is the number of sticks. Label your x-axis that this is a figure number. Show on your graph how you're working out the number of sticks at figure 8 by drawing a vertical line along parallel to your y-axis, and then read off the graph at figure number 17. The number of sticks is 17 for figure number 8. Then it says, where does the line cut the y-axis? Well, you read, this is a straight line graph. We can see that all the lines on the graph are going through a straight line. So extend the line back. Don't drop it down here to the origin. This is a straight line. So where does it cut the y-axis? It cuts the y-axis at the coordinate 0, 1. So the intercept of this graph is 0.01, the coordinate for the intercept. Then it gave you another graph and another series, and it asked you is either of these two graphs proportional? And when you look at the next figure number that they gave you, you again have figure number and sticks. But in figure number 1 you have 3, in figure number 2 you have 6, and in figure number 3 you have 9. So this is a totally different graph, which we'll represent with a different colour. And the formula for this one is easy, because here we have an interval of +3. So if we went back to figure number 0, we'd go -3, we'd get 0. Okay? So we can see that this one has no intercept. Because if we're then going to use our formula, n, what's the number of sticks? It's the interval, the difference, times n, plus the intercept, figure number 0, the start number. The start number for this one is 0. So the formula for number of sticks in this one is just 3n. We know that there's no intercept because there's no number on the end here. So this one's going to be proportional. So figure number 1 has 3, it's the same point, but figure number 2 is at 6, and figure number 3 is at 9. So now we're going to have a different graph here that is going to go through the origin. And we should label the line. This one is not y because it sticks. The s equals 3 lots of n, and this one has the s equals 2n plus 1. Figure number, we can define that as being n here, and number of sticks we can define as being s on the y-axis. So to answer the question, is either of these proportional? Yes, s equals 3n is proportional. Is proportional. And that means that it goes through the origin. This one goes through the point 0, 0. If it goes through the origin at point 0, 0, then it's proportional. Okay? Get it?